both blocks are on a plane inclined at an angle of 30 degrees to the horizontal. Then block Q is pulled by a constant force of 40 Newton, right, at an angle of 25 degrees to the inclined. Then block P moves on a rough, right, on a rough, this is the note, block Q, right, which is block Q, block P, I want you to note this, block P is the one that is moving on a rough horizontal surface, right? What does this mean if they say on a rough horizontal surface?
What does it mean?
Yes. So which force do you have there if they say rough horizontal surface or rough surface or rough section?
If they're saying it's moving on a rough surface, does it mean that it's moving at a lower velocity or acceleration?
All right. So once they say a rough section, you have to know that there is a frictional force. Okay. So there's a frictional force. Okay. So once they're saying an object is moving on a rough surface, so you have to know that there is a presence of the frictional force. And then now once they say the object is moving on a smooth surface, you have to know that there is no frictional force. Okay. Any question here?
No.
All right. And then they are saying of an inclined of AB and the inclined while ball Q moves on the frictionless, right? So Q is the one that is moving on the frictionless. So there is no frictional force for block Q. So for 3 kg block, there is a frictionless, so there is no frictional force. Okay, and then BC of inclined. Okay. So see the diagram below. Now the first question. For the first question, they are saying state the Newton's second law, and then you said it is the product of the force is equal. Okay, so the Newton's second law, if you have to state the Newton's second law, it is the law that is usually found when you are doing the Newton laws, right? The Newton topic, that's the first law. So when you're stating it, you're saying when the net force is applied in an object, the object will accelerate to the direction of the net force with the acceleration that is directly proportional to the net force and inversely proportional to the mass. Okay, so that is the Newton's second law. Do you understand?
Okay.
Yes. So when you're stating it, to make sure that you understand it. So they are not saying define Newtons. No, they are want you to state the law, right? So make sure that after this you go and study the laws. Newton first law, Newton second law, Newton third law, right? Because in most cases they will start by asking you the law, okay? Before they will start asking you the law before um uh before they ask you the question, right? So the goal for the reason why they are start asking you the law is because they are trying to tell you that the law that is going to apply in this question is this law, basically. Okay, so you need to know how to state the law. Okay.
Yeah.
All right. So make sure that after this, or when you have time, you study all the laws. You don't go for the exam. You don't go to write an exam without knowing all the three laws, Newton three laws. Okay. Now, and then the next question, oh, by the way, let me read the statement. They are saying the average the average constant friction force of 2.5 Newton act on block P as it moves from A to B, right? So now they told us the frictional force for block P, since they also told us that block P is moving on a rough surface. As I said, that when an object is moving on a rough surface, that means the frictional force is there's a presence of a frictional force. Yes. So now they just told us the magnitude of the frictional force. Okay, and by definition, we know that the frictional force is always opposed the motion of an object. Okay, so if the object is moving upwards, so the frictional force must be facing downwards. Okay, so you can see that since this object is connected, since this block P is connected to block Q, and you can see that block 3 is moving up the incline, so that means it's pulling block P up the incline also, right? So this tells us that the frictional force would face that direction. Okay, since the object they are moving that direction. Any question here?
No.
All right. So that is very, very important to understand. All right. Now, now, the next step, they're saying draw the label free body diagram for block P. Now, most of the time, uh, I usually suggest that you try to draw a faint um, surface, right? I usually suggest this for most of my clients, and I will also suggest this for you, right? You draw the faint line, which is represent the surface, this line which will represent the surface of the incline. All right, so the reason for this line is for you to able to draw the free body diagram correctly, but I can see that you drew the free body diagram correctly, but there's only one thing that was left. All right, so and your labels, I don't think they are that correct, because you said FA, right? I'm guessing maybe you are saying F apply. Now let's do this to be practical, and you have to understand the forces. So you know that when you are drawing the forces, when you are drawing especially these forces, must be parallel with the surface. So the surface, since is an incline like this, I will have the dot over here, right? And then obviously we know that the normal force is drawn perpendicular to the surface. Since the surface is like this, obviously the normal force um, will be like that. So that is F normal. So there's normal force, and then obviously there's a tension, which is that tension. All right. So
Yeah.
there's a tension, which is must, if you are drawing it, it must be perpendicular to the surface. That is the tension, and it must have the frictional force, because we are also told that it has the frictional force since it is moving on a rough surface. So it must also have the frictional force. Okay. And the frictional force, since this object is moving up the incline, the frictional force must be a little bit smaller than this force, right? Or this tension. And then it must have the weight, and the weight is always facing straight downwards like this, right? And I can see that your drawing it is looking good, right? In terms of the drawing. So I can erase this. I don't know. I don't know. I no longer need this, right? So I can draw the line that is straight like this, okay? So that is your FG. So I think your free body diagram is correctly, but your labeling, these three forces are correct. This one is the one that I don't understand, the way you labeled this. What force do you thought this is?
I thought that maybe P was being like they're applying a force on P so that it can move together with Q.
Okay. No, there's no force that was applied here, right? So since this force are connected by this tension, the only applied force is on block Q, right? So this block, when block Q is moving up the incline, it will also cause block P to move up the incline, because they are connected by a tension, by the same tension, right? And you have
Okay.
to
Yeah.
understand, I'm sure after this, there will be the calculation that we'll be doing. You have to understand that the blocks, since the blocks are connected by one tension, they will also move with the same they will also move with the same acceleration, right? So they will share the same acceleration. The acceleration that block Q is moving with up the incline, it will be the same acceleration that block P is moving up the incline, because they are connected by one tension, right? Basically, they are moving with the same velocity and the same acceleration, right? And at the same time, they are sharing the same tension, okay? But you have to understand that this tension is facing the opposite direction. Any question here?
No.
Right. So now, I think there's one thing that I have to do. Let me just. So now, as I was saying, so let's just redraw this forces. But before we do that, do you have any question according to the free body diagram for 2.2?
No.
All right. Now, in 2.3, they are saying calculate the magnitude of the acceleration. Um, calculate the magnitude of the acceleration of block P while block P is moving on section A to B. Now, um, you can see that section A to B, that is the section where block P has the frictional force, right? But the most important point is this. Since this block is moving up the incline, it is caused by block Q to move up the incline, right? That is the most important statement that you have to note. And the second step and the second information is this. Since the two blocks are connected by one tension, they will also accelerate with the same acceleration, right? So now,
Yeah.
the first step is to able to have the free body diagram of both the blocks, right? You'll see why the free body diagram are very important. So we already drew the free body diagram for P. If you can redraw it here, we said for P we have the normal force, which is like this, and we said we have the tension, and then we said we have the friction, and then we said that we have the weight. And we know that this weight would break into component, right? So this weight would break into component, which is Fg, but I will come to that. All right, and then we have to draw also the free body diagram for block Q. So for block Q, so for block Q, the free body diagram, we know that we have the tension because they said block Q is moving on the frictionless section, right? So that means the frictional force, we don't have the frictional force on block Q. So block Q, it will have the applied force, which is acting, okay. And also here, I would like to draw the inclined, right, to represent the inclined so that I can have my free body diagram correctly. So I know that if I represent the inclined, I will have that. So I will have the normal force that will be perpendicular to the surface. So that will be your normal force. And then I will have that force, which is applied force, which is acting at an angle, right? So it's acting at this angle of 25 degrees, which is applied force. I'll call this FIA. And then we'll have the tension, okay? We have the tension, which is that direction. And we have the weight, right, which is facing downward like this. So what I can just do, I can just quickly erase this, okay? Quickly erase this, and then I'll draw the weight. So the weight is Fg, right? So this is the free body diagram. This one is the free body diagram for block. This one is for block
For block Q,
P,
block P,
and this one is for block
Q.
Q. Any question here?
No.
Right. And then what do we have to do now? We have to compute the net force, right? And we know that by definition, by using the Newton's second law, we know that by definition, net force is equal to ma, right? The net force is equal to the mass times the acceleration, right, of the system. Now, now,
Yeah.
now, the first thing that we need to know, right? You can notice that we have the same tension. We have the tension here on the P block, and we also have the tension of the on the Q block. And you also have to understand, and you also have to note that this tension is facing on opposite direction. That is very important, right? That the tension will be
Oh,
facing on opposite direction, right? That is very, very
yeah.
important. Any question here?
No.
Right. So that's the first step. And the second and the first thing is to compute this, right? The net force. And when you are computing the net force, you need to deal with each block, right? And then you move on to the next block. If we start with block P, and actually what we need to do, we need the forces that are parallel to the surface. So we actually need to calculate the net force of the forces that are parallel to the surface. So the forces that are parallel to the surface, I'm talking about these forces, okay? And these forces are parallel to the surface because the surface in this case is an incline. And remember, the
Yeah.
weight will break into component, right? Actually the FG perpendicular, which is the component that will be like this. I'll call this one FG perpendicular, and there's a one which will go down the incline. All right, so
It's
let me,
parallel.
Yes, I'll draw it here. So this one is FG parallel, right? If I draw the line that is parallel to this FG parallel, I'll draw it here. I would have the right angle triangle. So my FG parallel will actually be here, and then here I would have my FG perpendicular. So I can quickly erase this. And then the angle, which is this angle, will be here, right? So you can see that I have the right angle triangle, right? So if I can redraw it for you, I have the right angle triangle. Can you see that?
Yeah.
Okay, so using this right angle triangle, I can actually use my trig function to find the component, right? But the important component here, the first one is because they already gave us the fractional force, so we won't calculate the fractional force. So the component that is very important is Fg perpendicular, because uh, since this force, which is the weight is breaking into component, it's got the weight, it's got the component that's going down the incline, which is also contributing to the forces that are acting parallel to the surface, which is this forces, right? So if I'm computing the net force, I would have the net force here for let me specify here for the net force for block P, right? So I'm dealing with block P. So the net force for block P is equal to, I will take upwards as positive. By the way, let me say this. It is very, very important, right? The tension must have the opposite signs, right? If you choose this tension to have a negative sign, this one is the mass that's got positive sign, right? And
Okay.
if I choose this one to be a negative, obviously this would be positive. This one is the mass now, it must be negative, and the one that are facing upwards must be positive. Do you understand?
Yes.
Right? So okay, if I choose this one, this must be okay. No, if this one is negative, this would be, if this is positive, no, what am I doing now? Okay, let me redo this. If I'm choosing this sign, which is this tension must be positive, this one must be negative. Okay, obviously this one must be negative, right? Obviously now, since this is
Yes.
positive, this one must be negative. Sorry, this one must be negative, and the one that at this side must be positive.
Positive. Yeah.
Does that make sense?
Yes.
Okay. Now the net force of the forces that are acting on the block P, right? So the forces, and as I said, we only consider the forces that are parallel to the surface, which is actually tension, the frictional force, and Fg parallel, right? So that means here the forces, and I will take this one down as negative, so I would have negative fraction plus negative Fg perpendicular parallel, and then plus tension. This is also equal to MA, right?
Yeah.
MA, right? And then remember, I already got the mass, so I can just quickly plug in the values. But before I plug in the values, I can actually distribute, I can actually find FG perpendicular because this is the component, right? So I can use the trig function because it is the mass for me to use the hypotenuse. And the hypotenuse in this case is just a simple FG. And the opposite side is FG parallel, right? Which is the one that I want, right? So I can actually use sine theta because sine theta is opposite of a hypotenuse. So I can quickly say sine theta is equal to FG parallel of a FG, right? And if I cross multiply, I would have FG parallel being equal to FG sine theta, right? So I can quickly replace, or I can just rewrite that here. So I can have minus f fraction minus fg sine theta plus t equal to the mass of block P is 2, so I can have 2a, right? Now Fg, if you remember correctly, Fg is nothing but the mass times the gravitational acceleration, because Fg is actually the weight. Okay, so I can quickly
Yes.
replace this Fg right, by mg, right? So now I can just,
Yes.
because I already got the tension, I can just quickly put in the 2.5. So this is 2.5 minus mg, because Fg is equal to mg, which is the mass times the gravitational acceleration. So the mass of the block P is 2, so that is 2 times 9.8 times sine 30 plus t equal to 2a, right? So can you please punch this? Negative 2.5 minus 2 times 9.8 times sine 30. What is the answer? What is the number that you're getting? Listening. Let's do it this way. We have minus 2.5. Can you please punch 2 times 9.8 times sine 30? What is that?
2 times.
9.8 times sine
I'm showing
30.
you how I.
So that is negative, it's 19,37, right?
7.
Plus t equal to 2a. Now, what is minus 2.5 minus 19.37? Okay, so that is minus 21,87 plus t equal to 2a, right? So now what we can actually do, we can just rewrite this because now we have the simplest number. So let me just rewrite it here, okay? So this is your equation 1, right? Any question here?
No.
Now we are done with the block P. Now let's go to block Q now, right? So for block Q, right? So for block Q, we also have to consider the forces that are acting perpendicular, sorry, that are acting parallel to the surface, right? So you also have to break the weight into component, and you also have to break the applied force into component, right? Because you can see that this weight would also break into Fg perpendicular and Fg parallel, right? Which is the same thing, right? So we have Fg parallel also here, and we are not done yet, because this applied force, it will have, right, it will have the FAY and also FAX, which is actually what the force that you are looking for, right, which is this force, right? So if I'm drawing the line, or if I'm drawing the force that is parallel to FGY to FAY, right, so I can draw it here, and then I will have the right angle triangle over here, which is 90, and then I can have my hypotenuse as FA, right? And you can see that I have my FAX, so I can actually use the trig ratio to find FAX, right? Because that is the force that I'm looking for, because this is the only force that is parallel to the surface. As I said, when you're calculating the net force, we use the force that are parallel to the surface. So now this FAX, we can use cos theta, or you can use cos 25. So if you say cos 25 is equal to adjacent over hypotenuse, so adjacent is FAX and hypotenuse is FA, right? So FAX will be equal to FA times cos 25. And then we have FA is 40 Newton. So can we please punch this? So um, let's quickly punch this. So we have 40 times cos 25. Any question here?
No.
So can you please punch this? What is 40 times cos 25? Okay, so that is 39,65 Newton. All right, so that is FAX, all right? And then let's also find FG perpendicular for this block. And we said that FG, the formula for FG perpendicular, sorry, for FG parallel, sorry, FG parallel is equal to mg, which is mg times sine theta. All right, so that will be, the mass of block Q is 3, so it's 3 times 9.8 times sine 30. So what is the answer here? What is 3 times 9.8 times sine 30?
But uh,
29,05. Okay. So now we have that force, which is Fg parallel. So now we can actually compute the net force. So we can take this one as negative. So we have minus T, right, plus FG parallel, or minus also because it's going down. That's why we take this one as minus now. Um, um, oh yeah, it's minus. And then we have minus FG parallel, which is minus 29,05, and then plus FAX, which is plus 39,65 equal to MA, and then the mass is 3, so it's 3A. So can you please punch this? Can you punch negative 29.05 plus 39.65? Okay, so that is minus T plus 10 comma
plus
6 equal to 3A.
0
So we can take this to the side, so we can actually take 10,6 minus 3A equal to T. So now we have the tangent equal to 10,6 minus 3A, right? That means we can substitute, this is our equation 2. So we can substitute equation 2 to equation 1, right? So what we can do, we can just say, okay, now we have minus, we use this equation 1, minus 21,87 plus, where there's t, we'll plug in 10,6 minus
minus
3a equal to
2A
2a, right? And then what is minus 29, um, 87 plus 10,6?
plus 10 plus 6. It is negative 11,27.
Then if we take that to the side, we'll add, we'll have 3a plus 2a, that is 5a, right? And then we can divide by 5 on both sides. So what is a?
Negative 11,2. So negative 2,25.
25 meters per second squared. So that would be your acceleration. Any question here?
No.